Hello. Happy Labor Day. No rest for the weary for me today. We have research to do. So, based on last week, and the week before that, and the week before that, I had a. Hang on, let me move some stuff out of the way. I had a fairly low opinion of quite a lot of the literature in RL already. It seems I was wrong. It is, in fact, much worse than expected. Nothing works. Practically, theoretically, nothing works. The only thing that does work is Puffer. So here's the question. Puffer is high data regime, low compute RL. That is what I've optimized for. That is what I've built Puffer for. If instead of doing fancy things, complicated new algorithms, if we just kind of re-optimize a little bit for sample efficiency, with a reasonable compute trade-off, not what's being done in the literature, not like literally 10 hours of compute to match 1 minute of compute in Puffer, but some reasonable trade-off. How far can we get? There. I don't think we're going to be able to get this. I don't think we're going to be able to match the sample efficiency of results on paper. But then again, those don't actually work. So we're going to see how far we can get. Most actual real-world applications do not care about this to the extent whatsoever as is presented in the literature. They just care about it to more of an extent than we have now. Also, I'm sick of driving myself insane dealing with fancy algorithms that do not work. So we're going to do things my way, and we're going to see how far we get. Hello, something. What do you mean sample efficiency doesn't work? I mean, why? Go try any of the methods from the literature, go try their reference implementations, try them on new problems, look at the code, see how fast it is, tell me if anything makes any bloody sense. I've spent 3 weeks determining that, in fact, it does not. Just adjust the mic so I stop clipping it. Hello, Jess. I believe I have some experiments from over the weekend. We had a fun power outage in my cluster, and the electricians have not set up the UPS yet for some bloody reason. So that means some stuff got killed, which sucks. Because I'm going to have to rerun some things. Yeah, so this was the old neural MMO run. It's a nice curve. We're going to have to go rerun it. What's the best paper on sample efficiency that you've read? Apparently none of them, because they don't actually work. There's literally not a single one that, like, I can say actually works. It's that bad. I can tell you well-written papers that don't actually work. But there's no point. Welcome, Weston. No, RL is definitely not useless. We have it working, and we have it working incredibly well in a range that's already very useful. So, we're absolutely certain that RL is useful. It might end up being the case, right, that there simply is not a good trade-off to get to the level of sample efficiency presented in the literature now. But even in that case, like, RL is still incredibly useful. It just puts slightly more emphasis on having good simulators. I certainly wouldn't have spent a decade on my life on something that I thought had the potential to be entirely useless. Let's take a look at some experiments. I did a few small things, okay? So, here was the first set of experiments I ran on Breakout. This is only 10 million steps. I literally just reran the optimization with a limit of 10 million steps. That's all I did. And you get close to solving. And then I reran with, I believe, a slightly larger network. And this is... I don't know if this is actually a full solve, but this is almost a solve, right? Like 850 plus typically. So this is like almost a solve with just a slightly bigger network. Admittedly, the trade-off is not great. You'd expect to get more out of the network size, but still. And then we had our more recent runs crash. So we really didn't get to see what happens over here. Okay? But I think what we're going to start with this. Let's grab this run. Yeah, these two are very close. You use transfer learning. That does not work at all. That I can tell you does not work at all. Why? Because, so if you're trying to draw an analogy between how this works in supervised learning, it's like trying to train on only cats, like classify cats, and then try to get it to work on some other random class. That's not how it works, right? If you want transfer, you train on like 1,000 different instances, and then you get it to work on a new one better. If you train on like one very narrow task, you're going to get a representation that's very specific to that task. Isn't that meta learning? Yes, that does not actually work across tasks. Like very different tasks. It works from distributions of tasks to similar tasks. Not exactly. That it doesn't map in RL the way that you expect it to map from supervised. Experience replay. It's not that they're useless. They are very useful, but it's architecturally very, very difficult to integrate them in a way that is sensible. Are off-pol methods completely useless? The current ones in the current state that they are presented, yes. I can outline the problem that you'd have to solve to make them to work, in addition to re-optimizing for like a more reasonable compute to sample regime. In order to make them useful, you'd have to solve the very short bootstrap horizon problem that they have. That's the main issue. It's that they have a very short bootstrap horizon, and actually they're not even off-pol, because as soon as you go beyond bootstrap horizon 1, you actually have an on-pol assumption, and they kind of just ignore that. And literally this causes like all sorts of different degeneracies. So, I mean, like I posted, right? I'm sick of clever researchers coming up with all sorts of very fancy ways to make things that only work on paper. Async PPO? Nope, because of the exact same thing with like the exact same on-pol requirement. The most reasonable version of this I've seen is cleanba, which is exactly one epoch off policy. That is a reasonable thing to do for like high throughput RL. What I'm doing right now is pretty dang good, I'd say. And even one epoch off pol can hurt you. I don't know if there's been a really good study. What you'd want to do is take cleanba and see how much it actually hurts you to be one epoch off pol. I imagine that it actually can be quite substantial. But that is the best thing that we have, in my opinion. Fill your replay buffer. No, you don't have a replay buffer. In that you have one epoch off pol, it's different. You can't just naively do a replay buffer. It doesn't work. I tried. Working on Labor Day? Exactly, it's Labor Day. Not sit on your ass and do nothing day. Ooh, this is sketchy. These hypers are sketchy, I can see. Well, we'll try them, but these are super sketchy params. Low clip coef. I'm actually like completely and utterly exhausted today. I have good reason for it. Hang on. Let me show off the the recent side project that I've been working on. No, I did not run a marathon. Not a full one. I mean, not recently at least. But what month is it? August? Alright, so this is why I'm freaking exhausted. We are at 130 miles in the last, realistically, 3 weeks. I did 16 miles yesterday, and then I got up and did 6 this morning, plus lifting. Yes, I will release an article, but I think I'm going to do it once I actually have some of this stuff working. Okay, yeah, so this was the concern. Whenever I see this param getting set this way, it's always like super unstable. Oh, you know what? I suppose, wasn't this a different number of M's? Hang on. Maybe I'm not being fair to it. You look like you lost some weight. I've lost a lot of weight. I'm at like a average cut of at least 1,000 calories a day. I'm losing like between 2 and 4 pounds per week. Honestly, that's the easy part. Like the cut, very, very easy. The training, not so much. What do you think would be a reasonable SPS goal for my chest amp? I'd chat with Bet a little bit. So I know chess engines evaluate like tens of millions of positions per second. The only thing I don't know with your chess env is because if you have the gigantic flat action space, that is going to cause data transfer issues and such. Like that's going to make the training difficult to be fast. I don't know if there's like a reasonable multi-discrete representation, right, that you could do. You might have to look into that a little bit. But like the actual game, I don't see any reason that can't be a million plus SPS. Eating food is easy, not eating food. Other way around for me, man. I still have to stuff myself to get all of my calories in, even on a cut. It's not that hard. Okay, so this is better, but not amazing. What are you working on today? I'm just going to try to retune a little bit for higher sample efficiency. I'm going to play around with some different techniques to enable scaling to slightly larger networks. Just some basic things. Yeah. The other thing that helps is it turns out when you go run 16 miles, like 12-ounce steak and eggs for brunch, and then like steak dinner counts as being on a cut. If you just burn a stupid number of calories. Well, to be fair, man, I ran the first half marathon of it, and I had to walk the last couple miles home. It was brutal yesterday. It was over 90 degrees in direct sun with no breeze by the time I finished. Like I did a half marathon last weekend, 8 out of 10 effort, no preparation, no supplies, easy. This weekend I was like dying, and I prepped it as well. I had Gatorade packs with me, I had shot blocks, I had electrolytes. I went through like 10 plus bottles of water while I was out there, and I got back. The entire hat that I have, it's like crusted in salt all the way through the hat. It's just like insane. So yesterday was brutal. Yeah, it's not a cooldown when a decent chunk of those are just like brutal hills. Yeah, that was rough. 5-10 pounds in water. Yeah, I actually replace it though. There's a water fountain every 5K. So every 5K I would drink, like I'd fill my bottle up, I'd drink a bottle of water, I'd fill the bottle back up, add a Gatorade pack, and then I drink that on the next lap. So I was getting 2 bottles of water at least per loop. Off Paul, I tried SAC. I tried like Mr. Q, and then I guess world model based stuff, Dreamer. Nothing works. Like literally nothing works. Is reward from breaking blocks delayed? I mean, credit assignment is generally like one of the core challenges of RL as a whole. So, yeah, the way to think about why I do why I do so much stuff on Breakout, you're thinking too much about the reasoning behind it. It is that empirically, Breakout is very fast to solve, and it is the simplest task where when something does well on Breakout, it is actually typically indicative of broader progress. Why did you post a ton of results but not label what the curves are? Man's got to have his secrets. I don't know. Sometimes I just post random sweeps, Kevin. All right, this one looks better. This one has like a non-stupid clip coefficient. So if we're going to do any sort of analysis, it's going to be off of this one. Yeah. Although I wanted to just do it for learning. Wait, C for future works. Overall, you think I should leave it? What do you mean? Wait, off Paul. Although I just wanted to do it for learning C. For future, I was thinking using off Paul for experience replay since past. Well, I just wanted to do it for learning C. I don't understand how those two things go together. So here's the tough thing. Let me be very clear about this. Off-policy algorithms are fundamentally worse than on-policy algorithms because they don't have the nice long bootstrap. They don't have generalized advantage estimation. It's not easy to learn value functions. They compensate by doing a utterly stupid number of updates on the data repeatedly using a replay buffer. So if you invest the same amount of compute, you're going to do a lot better with on-policy than you are with off-policy. If you crank up the compute ridiculously, though, off-policy will do better. Sometimes. Not even consistently. Because most of these off-pol algorithms actually have implicit on-pol assumptions. Just not as strong ones as you'll find everywhere else. You can make a project to train an RL on a CM to learn how to make an image. DIP techniques, pixel by pixel. I don't know what DIP is. Just generally, I would suggest making any environment that actually makes technical sense, like this is a reasonable problem that you think you can do with RL, and that you're going to be interested enough to actually do and complete, is generally a good enough idea. Like, you want to be doing cool projects that are, like, interesting in some new way, cover some, like, aspect that maybe we haven't considered, and that you're going to have enough fun doing to actually complete. Typically about it. Using pure... I don't know how... You just have to come up with a reason for, like, how on earth that's an RL problem, right? So you don't want to just, like, turn a sequence modeling problem into an RL problem. There actually has to be a meaningful element of interactivity for it to make sense. Process. What do you mean the standard is just MLP? Like, our standard is LSTM. What's the thought process for using LSTM? It's very simple. The reason people don't use LSTMs is because their code sucks and they don't actually have, like, an implementation that can do it fast. If you can do it, it's just better. It's like the single most stable thing that we have, like, working well, is just having a good LSTM implementation. There's literally no fundamental reason not to do it. It's just the standard because people can't code. Literally it. Like, if you go check the standard implementations, SP3 doesn't even have it. And if you check CleanRL, they do it in this really inefficient loop that makes everything 5x slower. But if you actually do it correctly, it's an incredibly efficient architecture. And it's like a really, really good backbone. LSTM isn't that hard to code, though? Oh, really? Go take a look at the Puffer implementation and then tell me if you think that. Yeah, their contrib technically does. They never got it in the main repo. Which is kind of funny with how core it is. Okay, so this is like 700-ish. 700 score. I'm not trying to be a dick, by the way, Kevin. It's just like, it is actually hard to do it in a way that is fast. Like, it's not trivial. There are like a half dozen ways to do it wrong. How did you know to use LSTM when you built Puffer? Dota. It's the core piece of Dota. Good enough for me. I don't know how you form vision as an RL problem efficiently. Is it possible that LSTM was 1K? Maybe. But the thing is, so RL's never just memory, right? It's also credit assignment. So you also have to get credit assignment to work over that horizon. And if you want credit assignment to work over that horizon, then, like, effectively, you want gamma times lambda, not just gamma, but you want gamma times lambda to be very high. And empirically, that doesn't seem to happen. So based on the hyperparameters I've seen for optimal runs so far, I would doubt it. And there's really no way to get, like, the 1K plus step memory without horribly inefficient and, like, slow models. Agent controls the cameras. So, but, like, why don't you just do supervised? Like, supervised learning is just easier than RL, right? You get way more signal. So it's not like, generally you don't want to try to form supervised learning problems as RL problems. You're looking for problems that can't be done via supervision alone because it's fundamentally interactive. That's what you're looking for in RL. Yeah, exactly. Yeah, 1/3 the infra. This is also true. RL is hard. Like, RL is legitimately hard. Okay, so these runs were just kind of lucky. I don't think that there's, like, a huge difference then between this one and... There's still kind of a difference, right? Yeah, no, there's still kind of a difference. Okay, so we get 700s out of this. I hate in RL is that for things we can solve much easily, we do a lot of effort. There are a lot of problems with RL itself. Yes, there are. I mean, you see, I'm here trying to fix them, though, right? There are a ton of problems. This is what I do. I fix them. Okay, so best solution, Professor Oak. It might not be for Pokemon specifically because that env is so slow. That, like, honestly, you would have just not had that hard of a time with that problem if Pokemon ran a million steps a second. Like, just the amount of problems that just go away with high sample, like high simulator speed, it's a lot. I solve problems. What is Neptune's site you use? It's an alternative to WandB. Simple grid base with a deterministic end. Not a single work on sparse or yeesh. You can see we have plenty of sparse reward RL working, right? Okay, so things to do from here. There are a lot of different sweeps we can run, right? I should probably be able to, like, pretty easily spin up Did I literally forget what I named my machines? Jeez. Hang on, let me go check tail scale to make sure they're up, and then I haven't just forgotten. Oh, what? These are down. Oh, that's awkward. Alright, let me send a message over. Weird. Yeah, I didn't forget. It's literally, they're just down. Okay, that sucks. Well, we'll have these rebooted shortly. In the meantime, suppose there are a few different things we can do. If I set frame skip to 1, 40 mil frames, we do better. We'll see what this does. Okay. Well, this is going to be rebooted momentarily anyways. Man. Okay, so there is actually a self-consistency loss. Okay, here. Here's the ablation. Ooh. Plus n equals 10. What is standard? No weight decay. So actually, it looks like these resets are the most important thing. Interesting. Weight decay. Annealing. I actually do wonder. We've never played with weight decay. It's possible that when you play with larger nets, you need weight decay. Actually, this... I do wonder about this, this scaling here. There's probably a fair bit we can do. Increasing discount factor. This could be good for both. Overfitting because you don't have enough data. So Weston, the motivation is because we're trying to do lower data regime. So in the lower data regime, if you over parameterize, it's possible, right? And we can also very easily just test it empirically. There's not a big... This is not a huge thing, honestly. It'd still be a worse way of doing things. The point here, Weston, right now, if you have a fast simulator, Puffer is the best thing out there. Puffer also gives you some tools to make your simulator fast. You can't always make your simulator fast, though. What I'm trying to do is I'm trying to expand the range of problems for which Puffer is effective. And I'm trying to do so smoothly in a way that doesn't really have any negative trade-offs. You see what I mean? Very funny, Jess. Oh, you dummy. I forgot, hang on, there's a key hyperparameter I forgot. Hang on, let me not be dumb. Oh, it is one epoch. That's bizarro. Like example. Full games, fancy robotics M's, existing industry sims in a variety of fields where they want to like try something out before rewriting a full-on sim. How much variance between training runs? No, those are different hypers, Tim. That's not variance across runs. Those are completely different hypers. It's expected that there's that much variance. Puffer's pretty good on not having crazy variance for most M's. And welcome, Tim, as well. This is kind of funny. Look at this. Some of these sample efficient algorithms actually just stop being good when you train them for longer. That's hilarious. That's actually consistent with what I saw. Pablo generally does pretty good work. I think just like off-pal stuff is super cursed, so I don't trust everything. But Pablo generally does pretty good work. I've chatted with him several times at different conferences. What did these guys get on, you put the full Atari results, right? Count. Here, 370. This is respectable. I always look to breakout. That's my like go-to task. Ooh. That's kind of promising, no? Not kind of promising. But we're gonna just have to do... and go to the new box. Tiny. Yay, rebooted. Is it Jay Suarez? I'm so confused. What happened? Why do I not have... Eh? Oh, there it is. Forgot about the username being different. Okay. This is gonna honestly... like... this is gonna be much more chill this week, doing this type of stuff for a little bit. My brain needs a break from banging my head against overly complicated things that don't actually work. It's very demotivating. This is gonna be way better. Okay. Okay, this is fine. Yeah, but we're gonna fix that. We're like actually gonna fix that. I almost feel like it would have been better for me to take some time off today. I'm like friggin' smoked. Yeah. Well, I think I kind of am doing that now. This is gonna be pretty easy work today. At the very least, we do that. We'll see. I might do shorter hours. It kind of depends on how the work is going today. I might end up doing shorter hours. I might, if I'm making progress, I'll be here all day, though. The run yesterday, like, really did a number on me. I was expecting to do a hard run. I thought I was going to get, like, between 16 and 18 miles. I did not expect it to be remotely that hard. Like, at all. Was it 128 times 64? Yeah, it's fine. I do have more coffee, though. Why do you think RL almost don't leverage RL more for coding tasks? They are doing that. That's exactly what they're doing now. Their shit is slow because their models are slow, and RL likes lots of data. It's also very difficult to teach because, like, the learning signal for programming is not trivial. Yeah. I mean, the thing is, at least in RL, even before the model scaled, like, the researchers and PhD students just wrote such shitty code that their stuff didn't work anyways. I'll agree, though, in natural language processing, at least, before transformers, it was substantially easier to do research. Now, I mean, I will say that, like, you shouldn't just try to fight that stuff head on, right? Like, if your idea is, oh, all these, like, big models, you need big models to do stuff, well, I'm gonna just, like, not do it. Like, I'm gonna just try to do big models anyways, even though I don't have any compute, and have, like, a horrible research cycle time, etc., etc. Like, you're just not doing stuff reasonably, right? At that point, you shouldn't be doing a PhD, you should just be going to industry. If you have things that you can explore without being super constrained, that's a different story. Well, because Jess, like, the thing is, they're kind of right about this in some ways, at least. Like, when I was doing research in natural language processing in 2017, you needed a different PhD for translation or for language modeling or for, like, semantic analysis. They were very different problems with distinct methods. And then they kind of just all got sodded with the same approach, right? Similar stuff happened in Vision a few years before that. But at this point, you are correct that people are trying to overgeneralize in some sense where it doesn't even remotely make sense. Yeah, you can't do anything, like, you should not be doing VLM research training as a PhD student. Like, you're just not going to have a good time. I don't know why you would set yourself up for failure. Robotics it is. There's tons of stuff that you can do. You just have to be a bit creative. Now, to be fair, I will give you this, though, right? You can definitely make very good scientific progress without having a ton of resources. Whether or not entrenched academic idiots will recognize, like, out there ideas and actually prop that stuff up is a totally different story. Being a PhD student is just generally not a lot of fun, even in the best of circumstances. At least if you're not doing, if you're not like the textbook academic, it's not a lot of fun. If you're working on a project area that's not super compute limited, that is actively explored, and you're working, like, within a realm of, like, algorithmically heavy things, right? And there have been many stages and many different subfields where this has been the case over the last decade, then it's a good time. Well, mostly. But that's a lot of ifs and buts. Does anybody know what a reasonable weight decay scale is for muon? Is it like E-4 or something? Transformers are a pretty dang different architecture, really. What's reasonable weight decay range scale for muon? All this. I don't know, is it 1e6? Is it 1e4? It's not like 1e minus 1, right? But it could be like -4, minus... I don't know. I just want a range. Rock take for freaking ever. It's on Lakers website. That's funny. It literally doesn't even give you a reasonable range. Stupid thing. All right, we'll just give it a wide range then. It gives me a total bullshit answer after all that. Weight underscore decay. As you use grok a lot, is there a reason? The models are all stupid anyways. If you see a lot of my work, there's pretty little involvement. Like, there's pretty little LLM involvement in any of my work. I don't know, I suppose I'm one of the holdouts. Like, I just generally do not think that these things are consistently useful. Grabbing that from Muon. Yeah, I know, but I didn't ask for LLM training. It just assumed. Because it's stupid. Good for generalization, not specific, so that's useless. Why are you adding the bot, Pepper? I ban, like, between 2 and 5 of those a day. Alright, that's weight decay launched. Cool. Very interesting. How much you're allowed to say? I can say everything. Anything I signed is long expired by now. What was your time working at OpenAI like? I've been very public in saying it's the best place I've ever worked by a mile. Like, it's pretty much the only place I've ever worked where at least the majority of the people there were incredibly competent, like, actually gave a shit about what they were doing. I was there when they were building Dota. I still consider that probably the most impressive technical project in RL of all time. There were like a whole bunch of different small, different sized, like mini research labs doing different stuff. Robotics was awesome. I directly used some of their domain randomization results in my work on Neural MMO. There was like a more fragmented multi-agent team. There was Alec that was there doing LLM stuff. Ilya was there. Greg was there, obviously. Everybody just like chatted about RL like and research at lunch all day. It was really great. Now, I don't know how it's changed since I've been there. I would assume that it's impossible to keep that talent density as you get larger. Um, at the very least, you can't keep like the small team vibes and like the different like focuses on different areas. I very much wish that they'd at least kept like 20% of their people on different areas of research. But like the rest of the field, kind of everybody consolidated 99% onto LLMs. And ultimately, we're going to look back on that as a detriment to science and something that delayed progress for several years. Which is why I'm here holding down the fort on RL, because I think that this is important. And all of my good friends who used to work on it for the most part, like very few of them are still in the space. And we lost some very, very good people to go over and work on LLM research. And ultimately, we're going to recognize that that was a bad move for science overall. But it's okay. I've got it. I'll make sure that at least this one piece of science that was cast to the wayside is done well and achieves the potential it should have achieved years ago. There you go. Other stuff to try. There is annealing and such. What do you hope the field will explore once LM dies down? Exactly what I'm doing now, right? I mean, there's other stuff I could do. The idea of like recursive self-improvement is pretty interesting to me as a whole. Like, why the hell do these systems not actually recursively self-improve? Like, at a fundamental level, it's kind of weird. That was the sort of the theory back in the day, right? That you were going to get an exponential takeoff. You weren't just going to get log linear progress with compute forever. And I mean, like, we have people now saying, oh yeah, that was just completely stupid. No, it wasn't. You have no idea what the hell could have happened, right? Everything's hindsight's 2020. You actually have no idea of, or understanding of how these systems might have possibly behaved or why. I suppose one theory is that they are exponentially improving depending on how you measure in some ways, but you're still not getting... Not in all the ways that you would expect, at the very least. Okay, so we've gotten a few different things done here, right? Now let's go implement a couple of them. Do we decay gamma? Keeping good samples is the value, right? So you can't keep good. Tim, I'm pretty sure that's the issue. It's difficult because technically policy gradient itself, even without the value function, the derivation assumes that the samples come from the same policy. But if you look at the final result of that derivation, it really does seem like it's just the value function. Hello, Nicholas. I'm currently doing MSc in economics, included in Python. I'm doing a project in Marl and repeated games. Want to know your advice on progressing in coding of this type? What do you think of Julia? Yeah, absolutely not Julia for AI stuff. You're going to be doing Python. Python is standard. All the tools that you need are in there. And then low-level stuff, if you actually need to do environment dev and stuff, I suggest C for that. And you can take a look at PufferLib as a very detailed example and all the articles we have on exactly how and why that works well. We're not too early to explore the stars. At least I hope not. There are lots of problems for me to solve after this. I don't necessarily see myself doing, like, core RL research for the rest of my life, right? In my mind, this is a problem to be solved. I'm going to solve it, and then I'm going to do other things. Maybe take a little break in between. Alright, that's like a good number of little things tried, I think, with this. We can reserve those last 2 GPUs for whatever I come up with based on this thing. Is there any way to do resets? I don't know how much I trust that, like, no resets thing as well. It's kind of nuts, right? Have you tried Gymnasium? No, I've only spent the last 2 years working, building a framework around it and replacing it. Oh, at Nicholas. I see. It was sarcastic. My bad, Jess. Yeah, Nicholas, if you just take a look at Puffer, it's literally 1,000 times faster. Like, check out the Discord, join up, take a look at, start, like, running some experiments there. You'll see the difference immediately. No, this is not about not resetting the env. This is them resetting the network weights. There's, like, this weird thing with plasticity, where, like, the net is easier to train for the first many updates. It's a really weird thing. I was like, what the heck is that question, Jess? Is like, this person just like not? You've been around for a while. You're just like not seen it, like watched anything on the screen. I'm pretty sure I have Gymnasium imports at the top of half of the files in here. Even though I'd love to get rid of them. Like, frankly, the only stuff we're using from Gymnasium for our custom M's would take me 1 day to replace. Word function sus. I'm sure it's a completely different context than what I'm doing here. Learn considerably. It depends by what. It depends on what you mean, Tim. Like, can they scale with more samples, with more compute, with different algorithms? What? Like, no, we're nowhere near capped out, right? There's a lot more that can be learned. What are your recommendations for new people learning RL? My recommendations for new people learning RL are... Hang on. Oops. To read the guide that I wrote specifically for new people learning RL. There are all of my best suggestions in one place for you. If you follow that guide and actually do what it says, then you will learn, like, you will know RL and you will be effective. That a Gymnasium SB3 rings. The slowing down. Update steps. I was running on some simulations in MATLAB. Step speed. I was referring to something completely different, Ben Vant. That can be an implementation thing, and it can be an env thing. The command to post this? Probably. I wonder... So is the correct thing... They say that they decrease N over time. So they decrease their bootstrap horizon over time. I think you have to increase it for... I think you increase it. Writing custom M's and learning, it's actually a really good resource. Yeah, that's what I try. The memory leak on it. So Benven, there are two things. If you have an algorithm that's off-pol and has a replay buffer, then yeah, it's going to get slower as the buffer fills up, potentially, if it's not implemented well. And two is that if the agent is getting better, the environments can slow down. It depends on the task. Typically, you want to profile stuff. Also, 40k steps per second anyways. Like, oh, I guess I don't know the speed you're training at. Typically, we're doing our experiments at hundreds of thousands to millions of steps per second. Just in super simple repeated games with like Matrix Payoff, multiple agents. No point using Puffer or other better than Gem. You may as well just go ahead and implement the environment in Python as a super quick thing if you want, but Puffer is still good because like we have a fast, stable implementation with some substantial advancements that make it more stable and perform better. Like there's just a lot of good stuff in Puffer. Because you're not going to be able to use Gymnasium to train anyways, right? You realize this. Like, Gymnasium is not a training library. You still need to go get a training library, and ours is the best. If you don't want to use PufferLib, the next best thing would be to use CleanRL, because it's very, very simple, even simpler than Puffer, but it's not going to be able to get the speeds that you get out of PufferLib. And because it's slower, like, the default settings are not going to be able to get the stability that you get out of Puffer either. Definitely don't go for SB3 though, or something like that, or TorchRL or any of those. Mm. I'm currently coding all my algorithms by hand. Yeah, that's not going to work at all. I can guarantee you that's not going to work at all. RL is not a field where you just roll your own stuff when you're new, or even when you're substantially experienced. These things are incredibly, incredibly brittle, and especially if you're just rolling your own thing and just like testing it on your environment, nothing is going to work. Our implementations are tested across literally dozens of different environments and used by hundreds of people. I know that's not a fun answer because I also like to do a lot of stuff myself. This is not a area where you do that. Bits per second. M's in NumPy. Yeah, we do our M's in C. Then, like, everything is really, really fast. If you have to do a vectorized thing, NumPy is fine. But generally, it's... As the env gets more complicated, it's easier to just write your code. Like, you just get to write arbitrary logic and loops and stuff and not have to vectorize or anything. And it's just C, so it's fast. Like, even if you're used to high-level programming, it's definitely worth picking up. It's just so much easier. I'm doing, like, Q-learning. Do you think it's a problem? Yeah, because if you're doing Q-learning, then it's just not going to work. Like, if you're, like, basic Q-learning is just a terrible algorithm. Assuming you're doing deep Q-learning at the very least. If you're literally doing tabular RL, then yeah, like... But you're not, like... You're really not going to solve anything at that point. I mean, you're literally going to have a factor of 1,000,000 difference in speed if you're just doing like basic naive algorithm implementations from scratch versus using something that is well optimized. We can train networks from scratch on a variety of different tasks on one machine in seconds. At the very least, I would definitely take a look at it because it'll broaden your horizons quite a bit. Like you're actually not even going to learn very much about RL just by trying to implement your own Q-learning based stuff. Like you're basically just going to get really frustrated that nothing works and then stop doing it. I'm going to write it in C. I'm using SP3 implementations, deep RL. M's coded for NumPy. Yeah, so I would just do, I'd just take your env, write a super quick binding to puffer, even in Python, try that out, and then if you want to make the env really fast, if the env is a bottleneck, port that to C, and follow our guides on how to do that. For most things, you're going to be training millions of steps per second, and stuff will just work instantly. Massive difference. What projects would you suggest for somebody trying to get into RL? The stuff that's in my guide on X. Like, I basically take people through doing a series of, like, simple to more complex ends, is the idea. What paper are you reading? This is Bigger, Better, Faster. I'm not necessarily trying to replicate this or anything. I'm just looking for, like, what techniques help them scale a little bit. I'm trying to figure out how this receding update horizon maps to OnPol. I think the equivalent of this is actually going to be... Isn't it to increase the horizon in OnPol? Because you get a biased estimate in off-pol when you make the horizon longer, don't you? But then you get a less biased estimate with on-pol? It's interesting. Developing my final project in university, want to know if you have some favorite papers related to animal cognition that has practical examples. I do not know any papers related to animal cognition, and I certainly don't know any that have practical examples. I know a bunch of, like, sort of, like, predator-prey style motivated RL stuff, but the animal cognition is, like, at best, very, very distant. Paper authors. Sometimes they are. Honestly, some of the contributors in here have gotten to be very good. Oh, wait, wait, wait. Look at this. Huh. They use a crap ton of weight decay. Wait, this is weird, though. This is, like... This is not a normal value. Did they just go take this from... Is this an RL paper? Ah. This is not an RL paper? This is funny. They actually got a meta reviewer who's not a dick. Whoever this guy is, good job. Okay, so this is a different form of weight decay. Interesting. Okay, this is very different. Make sure to keep learning fresh. It's like a generalization bias. It's not relevant in what we normally do, but it is relevant in, or it's possibly relevant in the lower data regime. I implement some new systems with Puffer looking at electrical control system. Is there a way when I finish to send it through so others have access? Yes, absolutely. If you implement an environment and like working RL around Puffer, you just contribute it as an environment to Ocean. This is the standard way that we run the whole project. Welcome, Nico. What the heck? Oh, this is 8 years. Okay, this is like actual torch. Like Lua torch. Tch. Okay. So we'll try this for Muon, I suppose. Because presumably this is not implemented. We want, right? Oh, geez, yeah, Weston, this is... You do not know the horrors this field used to go through, alright? Lua used to actually be a step up from what we used to have to deal with. Original Torch was not PyTorch, it was just Torch and it was written in Lua. You had to do all your damn RL in Lua. Which, to be fair, it's not terrible, but like... there's no good infra around it. Is there a good version of this? Oh, it's freaking Jax. Go ask Grok again. I actually don't know. Okay, actually, we can do this. It'll be faster. Google it. Being on kinematics, we say better. Okay, I'm not a roboticist, man. First dynamic for cholesterol. I'm not a roboticist. All I know is you need to keep the simulator fast. And not try to like make it high fidelity before you know that that fidelity is actually needed. Oh, I see. Adam W. I see. This is actually Adam W. So then, do we think it's implemented correctly in Muon already? Probably. Given that it's the shared with Adam W. Let's see what we have on our experiment so far. Well, you think my Q learning would be problematic if I don't use a training library? Isn't it pretty common to make all the code for it, especially considering it's a... Are you doing tabular learning or deep Q learning? Like, basically anything more complicated than cart pull... Yeah, then anything more complicated than cart pull, you're gonna not have a fun time. It's not pretty common to make all the code and actually have it work. Like, you do not know the horrors that you're about to inflict upon yourself. Interesting. Ah, very nice. You very well should be. If you think that RL is just like one of these things where, oh, you know, I can learn by implementing stuff from scratch and I'll get a good feel for how these things will work, like that just simply does not work in this field because the algorithms are far too fiddly and brittle. Like, you really, really, really want to start from something that is fast and stable, and the fastest and most stable thing now is Puffer. Okay, so I mean, we have a lot of different things in here that collectively we should be able to get something out of, right? And presumably, is this the one that's screwed? Oh no, that's not the one that's screwed. What's the one that's screwed? This one? Hmm. Oh, probably. Yeah, so this warm-up steps, I see. Should be set to something like 100, no, 1,000, like 200. Let's see. Funny, it sounds like you just described C++ to me, man. Worse than C++ is pretty damning. What's this beta 2 scale? Never messed with this. I think then this is... Do I want to mess with these resets? I mean, this resets thing is pretty weird, right? Okay, so it's the discount factor annealing, the update horizon, and larger nets. Possibly the resets. I'm gonna have to think about the resets, because, like, there's literally not even a way to do that, is there? I don't think there even is a way to do it. Dreamer and Mr. Q failed. They're quite bad. Yeah, we're not porting shit to Rust. Screw that language. Yeah, so we got a world modeling based thing to solve Pong in like a reasonable number of steps as well, like a very reasonable number of steps. And it just wouldn't work on anything harder. And it's like super slow, and like the scaling trade-off is just not where it should be. And it's super complicated. And like in the best case scenario, if it were to work perfectly today, it would still be 3 months of infra work to try to make it vaguely efficient. For Mr. Q, not quite as bad. I don't think that these things actually scale well with data though at all. So I'm kind of just trying to see now this week. I'm sick and tired of these fancy algorithms, and I'm trying to see, just by doing relatively simple things, how much more sample efficiency we can get out of PufferLib. Because if I can make PufferLib, like, even if I can make it 10x as sample efficient as it is now, at the price of, like, not a crazy amount of compute, then we're already getting to the point where that's good enough for industry, right? Like in the vast majority of situations, you have a simulator. You can spin up more of those simulators. It's just that they're kind of slow. So like spending a bajillion GPU hours to save a few simulator hours is not worth it either. So like basically if we don't actually need soda sample efficiency, we just need a better sample efficiency compute trade-off. I can probably do that without going nuts. Alright, well, we'll try these things next. Use the restroom real quick. And get some coffee as well. We'll go from there. I'll take a second to walk outside a little as well. My legs are so stiff. All right. Scientist got some science fuel. Oh, yeah, I've seen that, Weston. Uh, I can't even say, have I ever done. Okay, I've never done something quite that stupid, but I've gotten close when I was new. Like, I've definitely gotten uncomfortably close to that. These decays are probably actually useful, right? The worst thing I've ever done, programming wise, was in my first research internship. I had to write code to process a word graph when I didn't know what a graph was. Meaning I didn't know what like search algorithms were. I didn't know what a node was or an edge was or what to even look up or ask. So I ended up with like some 14 for loop deep recursive function from a nightmare. And it did actually somehow work. But yeah, that should have been like 20 lines of code, not 2,000. So, not like I was just a natural at all this crap. I spent very many thousand hours doing it. Ironically, if anything, I was more of a natural at writing back when I used to do that a bunch. And I strongly suspect that was just from the ridiculous amount that I used to read. And lately, I still do. Just all audiobooks. That counts. Hmm. I'm trying to remember, because I stopped listening to books for many months. And it was actually kind of weird. I would always listen to audiobooks while I was running. And then when I got pneumonia, like like for a while after that, when I got out of the hospital, I just like didn't want to listen to anything at all running. It was kind of weird. I just wanted silence. But I'm pretty much back to full health now. Pretty much. Gotta finish this cut and rebulk, and then I should be good. Just audible Ben Vand. Audible. Favorite books? It's all fantasy and sci-fi, honestly. I don't really listen to a bunch of nonfiction. Culture series for sci-fi. Fantasy, I've been listening to The Furies of Calderon lately. Almost done with that. Aragon. I listened to that when I was way younger, and it holds up very, very well. I went through the whole Lord of the Rings series while I was running. That actually, I don't think that actually holds up so well. I find the writing quite boring in it. Red Rising. What is this? I actually do need new series recommendations. Dystopian sci-fi. I don't know how I like dystopian sci-fi shit, honestly. It kind of I had a funny discussion with Emmett on Twitter. I don't consider the culture series to be dystopian. Have I listened to Murtag? I think I did. I actually have zero recollection, though. No, I think I did, but I have zero recollection of it. No, wait, I think I do. Yeah, the Aragon series is amazing. I really like that. Movie, though? I don't watch any of the movies for these things. I've never seen, like, the Lord of the Rings movies or anything. I really don't watch. I actually can't even remember the last time I watched a movie. I think it was while I was still a PhD student. I watched A Few Good Men. I think that's the last movie I've watched, was like a year plus ago. In LSTMs, what is the intuition behind this part of the design? Output is dependent on hidden plus input, and hidden is extracted from cell gate. And gate is used in... Oh, man. Kevin, this is a diagram that everybody studies once when they're an undergrad, or whenever they're doing their initial ML. And then nobody bothers to actually remember this. And the reason for that is that it's backed by so many empirical ablations that, like, there's really nothing you can do by, like, fiddling with different gate structures that's better than this. Let me see. So one of these is a forget gate, where it's meant to let you, like, decide what information to get rid of. One of these is an input gate. I think there's, like, there are, like, two other ones as well. But what I would suggest is there's this, like, LSTM, like, Space Odyssey paper or whatever, and they go through all the different possible architectures, and you can't really do much better. Didn't I answer this before something? Did you miss my answer to this? I thought... Hang on. Was it you that asked this before? Well, whatever. I'll answer it briefly. Yeah, the quick answer, you can go back for my longer one. But yeah, it is the best place I ever worked. I was interning there for 6 months. I think I pissed off a bunch of Facebook people because I was gonna go intern for 3 months. Took 3 months off for my degree and I batched it with the summer. So I was gonna spend 3 months at OpenAI and 3 months at Fair. And I liked OpenAI so much that I just decided to not go to Fair. After I had agreed. So yeah, that probably wasn't great, but it was such a cool place. It was such a cool place. Um okay, then somebody else asked me. Like the Dota team there is still the most inspirational thing I've seen in research. And Alec was there. Alec was doing awesome stuff. Ilya and Greg are still two of the people I respect the most in this field. There were a couple people I didn't see eye to eye with. Little bit of internal politicking that was stupid, but way less than anywhere else I've ever been. It was a cool place. It was funny because I thought I was hot shit back then. And I mean, honestly, a lot of the stuff I said back then wasn't even like totally off. I'm way better now. It was a fun time. What do I know about DeepMind? I don't know very much about the internals of DeepMind, just what I can infer from their publications. I don't think that I would do as well at DeepMind. The my style of what I do is matches a lot better with OpenAI. DeepMind does too much math for the sake of doing math for my liking. Worked with Amazon. I took one random internship at Amazon during my PhD. What do you think about mini PCs people are promoting for running local models? You're gonna have to wait a while for like local models to catch up at a reasonable price for LLMs. I mean, obviously with my work in RL, right, you can do all this type of research at home. All our stuff is super fast. It's gonna take a while for the also catch up. I doubt people are gonna be buying $20,000 boxes for personal use. It's gonna be more the case that like it'll be an enthusiast thing, and then people will run local models when there are good ones that are just embedded in applications that they can just get. And maybe not even then. Jetson Nano is more for like on device, right? You can have a bigger box at home for this stuff, but I think most likely people are just going to outsource to the convenience of cloud with zero regard whatsoever to privacy like they always do, unfortunately. I guess we'll see. The best case scenario for that type of stuff is that somebody gets the best case scenario for this is that of all these stupid AI lobbyists that are just like trying to lock down the field, we get one good one who actually gets like legal privilege applied to LLM communications. That would be kind of funny. I don't know if that'll happen. How important is advanced probability, linear deep learning theory beyond the fundamentals? You'd have to ask somebody who knows that stuff. I don't. It literally knows cosine and alien. That's funny. Cosine, step over. Yep, this is a correct version. You were hypothetically offered 100 mil. Would you join? What's MSL? Microsoft? 100 mil for how long and in what form? Pretty much, like, what I'd have to get offered is either something that is like a natural continuation of what I'm doing now at larger scale that I think will be a greater benefit to science than what I'm doing now, and at least as good of a financial benefit to myself. Or I would have to basically be offered so much money that I figure I go do that for, no more than like 4 years. And then I have unlimited capital with which to just start my own scientific efforts for the rest of my life. It'd have to be like one of those two. Oh, Meta Super Intel. Yeah. Well, I don't know if he actually has been doing that or if that's like the rumor. $100 million signing bonus for I don't know how long of a contract. If it's a 2-year contract, then with like good additionals, then yeah. Like 100 million is enough to do a lot of science, but not unlimited science. I think 1 billion is enough to do like unlimited science. I mean, right, if you're not like a ludicrously high maintenance person, at some point there's like a number above which you can't possibly spend more on like personal stuff that to improve your life in any way, shape, or form. And then at least in my mind, the really big numbers are for doing cool stuff with. I mean, unless you're the type of person to go buy a yacht or something, in which case, okay. That is the story, apparently, Weston. His company. I don't know what he's doing. I just know that at least when I was there at OpenAI, he was one of the two people in the field that I respected the most. That is all I know. So take that as you will. Not having to think is quite boring, actually. Like, honestly, my ideal setting is pretty much exactly what I'm doing now, with probably a few more days off, but not as many as I would expect that I actually, like, think I want. If that makes sense. What's wrong with this stupid thing? So... let's see. Why was he overhyping the fuck out of... Because that major breakthrough was made at OpenAI, right? GPT was OpenAI. Like, GPT-2, GPT-3, that was OpenAI. He was honestly one of the first ones to really make the big bet on LLM scaling as much as they would. I basically told him that when he asked me, like, what do I think about compression as a general form of learning, I told him, like, yeah, I think it'll work. I think it'll get really far, but I don't think it's going to solve everything. I think you need RL for interactivity. So far, it seems to me that this is the case. Did they even partner with Microsoft by GPT-3? I thought it was like after, wasn't it? I didn't think they'd even done that by then. I don't remember if it was 3.5 or 4. Is this actually consistent or is this just noise? I think it's even better. Yeah, but when did they actually get like exclusives, right? There was like I think there were like different sizes of that. I don't remember. I mean, I wasn't there anymore. I don't have any inside information. Like, I think my publication was originally 2019 from them, but it had already been there for a while by then. Cool. Hmm. I think that the way that we do this, guys, I think we do gamma initial and we do scale. I think we do gamma scale. This. RL Tinder. I honestly think that's more of a human problem than an algorithm problem. So 1 minus the start divided by scale. This is kind of an interesting little thing that I've done here, right? This is like a hyperparameter amenable, like a sweepable version of cosine decay on this. So the idea here is that instead of specifying a start and a stop, because that's kind of hard to sweep over, right? Because like stop depends on start. You give it a scale, and that is like the reduction in distance to 1. So like if you do 0.9 as the start and a scale of 10, then it'll do 1 minus 0.9 is 0.1. It'll divide by 10, and then you'll get like 0.99 or whatever instead of 0.9. So you get 10x closer to 1. I think that's reasonable, right? Why not hard code it? Because if you hard code it, then you can't sweep it. You want to you want to optimize these things algorithmically, obviously, right? It'll dynamically change exactly. That's funny. Oh, why do I have this dumb preview live eating up my... Okay. This... Gamma scale. This is all fine. Reward based on the current one, right? How did you handle the algorithm part? Right here. We have a CUDA kernel for it. It's not a long piece of code. It's just Very crucially important piece of code. Excuse me. My gosh. What's wrong with me? Thank you, Jess. Okay. This is now push. Okay, this ought to be good, right? The exact same thing for all the hypers. Oh, we've got protein in Puffer, which is our hyperparameter algorithm. Quite good. Certainly hope it is. I spent long enough on it. Okay, so that's one additional piece. And aside from that, I think we can look at the architecture scaling for a little bit, right? How are we doing on experiments? Stuff crashing? No, it's just taking a while. This is totally broken. Oh, here it is. Interesting. These are all going to have to fully finish. What does protein do? It optimizes hyperparameters quite well. It's available as a standalone single file as well, based on a lot of my own research. All right, let me use the restroom real quick. It'll take a couple minutes, and then we're going to do possibly network scaling. Possibly network scaling. We'll have to see. You really should be able to do network scaling, right? I'll be right back. What do you mean, can I make it manual? No, you don't optimize the hyperparameters within a single run, okay? Like sometimes you specify that the hyperparameters are like a decaying value, right? So that they will change during the course of the run, but you're just changing like the endpoints or whatever at the start of the experiment. You're not doing like interactive optimization live. That's almost completely intractable to do efficiently. The thing I'm doing is much more straightforward and practical, believe me. Drink. God, I'm exhausted today. Holy. Coffee. That is like insane. Okay. Well, let's go check the Impala CNN. It's so funny to me how this whole paper gets remembered so much, but like half of this paper is just like, hey, what happens if we use a half decent architecture? So it's literally just like it's like conv relu conv plus. Oh, it's wait, so this encoder here, it's conv, and then it's relu conv plus relu conv relu plus. Okay, so this is the encode. We can do something like this. What makes an architecture good? That works empirically. You can do that, but I don't know what you're trying to accomplish. You're not going to be able to do that effectively. What the heck about the problem that you're trying to solve specifically requires that? Film helps, but barely. Applying film to my skip connections. Good job. Is it normal to be a stuffed chicken instead of an autoencoder? It's normal to be hungry enough to eat a stuffed chicken after working on autoencoders all day. I hope that helps. You push capitalism to the limits. I hardly see how that follows. Optimize the hyperparameters, not slowing the algorithm itself. Done with slowing the hell on the agent. Why can't I send links? Ask YouTube. I don't have anything custom set. I would heavily consider you to reevaluate your understanding of the world. That is not how that works whatsoever. There's plenty of historical evidence for that as well, if you were go look for it. Intrinsic interactive RL. Weston. Weston is funny. Intrinsic interactive R using error-related potentials for real-world human. Like, why? You're trying to do like this like RLHF thingy, and I don't understand why. Like, why do you need to do this for your specific problem? Contribute to the problem of blood. No, it's the exact opposite. That's not what I do. Chess. uh, ah. Intrinsic. Oh, so you would You can go look up like the Majoko backflip for that. I don't know what the paper's called, but if you look it up, that should come up. That's not messing with hyperparameters live, though. That's something different, man. That's the reference, though, if you want it. I mean, it's gonna be you if you're gonna be rude. Like, you basically came into the chat of somebody who is streaming all, like me, I'm streaming all my research. I've dedicated the last decade of my life to enhancing science, and you come in here asking me a bunch of bullshit about if I'm causing global poverty. With, like, absolutely no fucking context for what I'm doing at all. Autonomous driving cars training is safer. That is also different. So that is, you have brought up two different things, right? So one is interactive optimization. That's like the Majoko backflip. The other thing is constrained reinforcement learning, which is very different. You have two very different things you're mixing there. You can't not let do this. It can't be in modules. It's net. Jeez, Jess. I mean, seriously, like, replacing jobs and optimizing stuff, that's not remotely exciting to me. It's like, you can actually argue that there are, like, technological progress does require this to some extent, and often it is a good thing, because it creates other jobs on top of that. But, like, besides that, that's not what I even care about, right? I care about making some, like, real sci-fi tech you're just not going to get by any other means. So... Okay, so here is our new model. This thing is still fast, it turns out. 3.2 mil. Do we have... Not bad, right? How do you see RL connections to sci-fi tech? Well, PufferLib itself is kind of sci-fi in a way that we have brand new programmers making AI for their games without knowing anything about, like, game AI or search or classic methods at all, just literally by having the thing mash random buttons until it figures it out. This has, like, huge impacts for everything dependent on simulation in industry, as well as core areas of scientific research and other fields that depend on simulation, right? And if you think of, like, what if RL is actually fast and works across the board, that creates a lot of crazy stuff. Um, Superhuman logistics, superhuman optimizations in robotics and control, uh, accelerated progress in, like, materials discovery, drug design, like, lots of areas. Urban planning, elimination of traffic completely. There's tons of stuff that can be done. All right, no BDSM in my chat. Thank you very much. This is a research stream, sir. You have opened the wrong website. Yeah, yeah. The thing you don't realize, Pepper, is that as much as I am here entertaining you on the stream, you are entertaining me on the stream. Alright, like, enough of this, guys. Yeah, man, definitely get some help. If you're not just trolling. So we actually... You don't want to do this, right? I kind of messed it up. Well, it'll have to just do both. I actually went to NVIDIA last week, and I'm hoping we're going to be able to do some cool stuff. Especially around RL with their stuff. We're going to interactively tune hypers. The thing is something like... There's not a really good way to do that because the outcome of hypers being good or not is dependent on how, like, what they're able to learn. So, like, in order to do interactive hyperparameter tuning, you need to do something like population-based training. But that algorithm isn't designed for the setting you're talking about. Like, that algorithm is basically doing what you're doing, but it's doing it massively parallel, and it fundamentally doesn't make sense to do sequentially. The whole point is that it's parallel. There's no benefit to doing it otherwise. I think I did just do that, right? Yep. I hit the wrong command. Funny that I remembered. It can't, right? The whole point of it is that it's massively parallel. Like, interactive hyperparameter tuning kind of doesn't make a ton of sense. Like, you can partially sort of do a few things, but not like it's not like I see your problem go, oh yeah, you have to do interactive hyperparameter tuning. It's like I see your problem and think of 1,000 other things on the list first. Honestly, Weston, that's such a stupidly easily fixable problem. It's insane to me that with all the money that these companies have put in, they haven't fixed that yet. I don't know why when I open X, it just default links me to this random account. I looked up to see if it was available. Cool. That's totally the wrong window, right? Yeah, but literally all you would do is you would just make the output text editable so it could go back and edit. Like, you give it an editor instead of just a text gen. Okay, so we now have 6 GPUs worth of experiments running. It's 3:20. I have a couple more hours to do stuff. I'm exhausted. I want to do a bit more work. I think I want to do a little bit more work and end a little bit early. I don't want to just be done now. Trying to think what we can do. So let's put this over here, and then this goes here. What do you do after streams? For the past few weeks, I go either. Well, most days I walk over to dinner. On Monday, it's like the place I go to is closed, so I order something. And I usually spend most of my days. I listen to an audiobook. I get in the hot tub for a bit because my legs are shot from running, and I go to bed. Sometimes I'll play a couple games or something, but usually just like listen to my book, get in the hot tub, and go to bed early. I mean, my first, like, at least 2 hours of every day are spent on hard exercise. I need a lot of rest. I wouldn't get one that would, obviously. Duh. What the hell are they training it on? Just the current replay buffer? Oh yeah, they literally are just doing that, huh? So weird. There's no way to do this, there's basically, like, no good way to do this with online RL, right? Don't you think about building something to attract viewers? I mean, the type of viewers I'm interested in, right, for the most part, are people who want to actually get involved with the tech. Like, the goal is not to be like some random shitfluencer. The goal is to actually advance the science and have everybody who wants to be involved with that be able to. Is it possible to do something like weight switching to learn separate tasks or just learn one big... Kind of. You're better off if you... I mean, what are you trying to do? Is this for the quadruped? Like, you're probably better off just having an embedding of the goal. What do you mean by pseudo? So this is a weird paper in the sense that they're like partially resetting the network's parameters every so often, and then they're training, like they're doing additional training for on the new model, just using the existing buffer, the replay buffer. So this is like kind of specific to online, to off-pol RL, because you have this replay buffer. I do wonder if this is even a consideration for online RL. Because we apply so many fewer updates, this is probably nowhere near as much of a problem. Thing with Unity. Yeah, the problem is if you do something with Unity, it's gonna be slow as hell, right? I guess technically there are things I can do, right? But it's like, it's not going to be something that's as quick and easy as this. And if I'm doing stuff with Unity at that, like, I may as well do that for a company. Mostly stream the core research progress. Something in the future, my sort of end goal after I finish this in the robotic arm. Yeah, you can, a lot of the time, if you have the obs and action spaces still looking the same and you just have different tasks, you can just give it an observation of the goal embedding or like encode it into the reward. I did it for drones. It's fine. It just works. I suspect that this is not remotely as big of a deal. Right? Because the thing is, just the number of updates applied is way, way lower in on-pol. Yeah, there is kind of a Unity gymnasium thing. It's slow. I've seen the AI warehouse channel. That one's really cool. Oh, Weston, I forget. Is that the guy that you know who did Rainbow, or is that somebody else? Human bipedal robot learned to skateboard. Yeah, that's a pain. That's gonna be a real pain. Well, honestly, humanoids, are they that difficult? I know humanoid hands are very difficult. I actually don't know. It depends how many degrees of freedom you have in the bot or the model. You can definitely get like a bipedal something or other. Oh, you know what? Wait, IQM with scale. They probably have an ablation on this thing. Yeah, okay, AI Tango, right? I actually think of the off-pol stuff I looked at, that was one of the better things I saw. Like, I believe that guy actually made something work. I'm sure there's brittleness, there's like really a lot of complexity in the method and such. But it seems a lot better than a lot of the other stuff that's out there. I had like a very balanced approach. It's quite good work. Oh, geez, why would you ever do this, man? You have different axes on these. Okay. Wait, what? So this is worse? Trying to make Mario Kart physics using mustache to see. Yeah. What happens if you train Majoko for 1 billion steps? Well, yeah, like, stuff will work way better. It's just that the Majoko M's are slow as hell. You can actually do that on MJX, though. But the thing is, you can't do it, like, in Puffer, like, 1 billion steps, you do it in under an hour, right? Like, in some of our, depending on the end of, like, some of those are in, like, 10, 15 minutes. There's a massive difference in speed. Okay, so you know what? These are just not particularly good ablations, I think, is the problem. Yeah, these are, like, not particularly good ablations. Like, they're standard ablations, but I don't think that they're particularly informative. Joke of War, that's a new thing, I think, right? I haven't looked at Warp. I don't do primarily physics, right? It's general RL. Yeah, so this is just straight better than this. They perform linearly better, the quality slowed down. Typically, if you have stuff optimized well, then smooth, harder M's are log linear. Though RL curves can be a little difficult to predict. Like, sometimes you get all sorts of weird shapes depending on, like, whether the environment is structured such that there's just a very hard to discover trick, or if it's like a smooth, basically, like, is it the type of environment where you can smoothly improve, or you improve in big jumps by realizing stuff, right? Like, if you think about most games, like competitive games, a lot of competitive games are a combination of both of those two things, right? Same with RL. Okay, so this is just like do a batshit insane number of gradient steps, right? That's what this is. We have some init function I haven't played around with for a long time that is inherited from CleanRL. I like how it's saying it takes only 10 hours. It takes only 10 hours to train 100,000 frames. That is batshit. I mean, I think that the most amount of time we're willing to spend on 100,000 frames, like GPU time, is like minutes, maybe? Maybe 10 minutes? That's just impractically insane. What's this FBR? Well, in a parallel universe, the CPU simulating the ENV runs a million times faster as well, right? And then this method is like, whatever. In a parallel universe, people just write decent code that's actually fast. And then we don't have to worry about crazy sample efficiency barriers. Fast physics engine for robot. Is it good? It's kind of crazy that you can do this well just by doing a batshit number of updates, right? My research blessed in class, but is closed source. So tired. Imagine a world where people write efficient code. Like the vast majority of applications today are like could be 100x faster. Vast majority of production code's just garbage. Like your applications, your like stupid chat app should not take 5 seconds to load. They should load instantly. Like literally, I've kind of developed the opinion that if you just give your devs like really, really slow hardware, um, for use during development, like it's not even necessarily going to make it any harder for them to do their work, and then you'll get something that'll actually work fast on reasonable hardware. And go give all the devs like Pentium processors for running their code. Am I reading this right, that it's better? Oh, wait, minus... Okay. So possibly self-prediction thing. I should go look at the self-prediction loss. See what that is. This crash? My thing crash? %0? No? Alright, well, we'll see what this is, but... decent chunk of stuff. Hmm. Made a difference in Atari, right? Maybe you do just have to re-optimize the crap out of everything. Use the restroom real quick. I'll be right back. Neptune's done a weird thing. I think Neptune's just being crappy. Well, we're gonna play with a couple things, I suppose, here. Just for a little bit. Honestly, all these platforms suck. Can you summarize the advances in the algorithm of the model? The initial screenshot I posted was literally just the first sweep that I ran with limited to 10 million samples. So if you just run the hyperparameter tuner to optimize for something other than high data regime, you do a fair bit better. And now we're making additional changes on top of that. Heck. The other way around? That doesn't make any bloody sense to me. Hmm. Really, this specific learning rate is so magical. Hmm. I wonder if this is related to the gamma being screwy. 9, 995, 500. You got it? Crazy, that's worse. Actually, is it like the prioritization? Auxiliary self-supervision losses to work. Not yet, I haven't. There's evidence for and against those. Literally magic learning rate, that's crazy. What else we can do for this? I mean, I can mess with some things here, right? What happens if I guess hypers? What happens if I literally just guess my hypers? Okay. We're back up to reasonable perf. Weird. Hmm. Hmm. Why does it do that? Can hypothesize. So if I do like, you know, this doesn't instantly solve either. Okay. I kind of expected that to solve. 700. Okay, so something like this could work. Interesting. It's funny that we really haven't seen much out of model scaling at all yet, right? In fact, this makes it worse. 'Well, hang on. If I do like this, surely this is better, right? Okay, 420. Is this... What the heck part of degenerate search space have I gotten myself into here? Yeah, what the heck? I haven't done anything that should lead to degenerate search space, right? Aggressive off-pall. There's definitely something to sample reuse, but all practical forms of incorporating it have major issues. I'm running some additional experiments. Thing. So this is not super sensitive, it seems. I mean, I shouldn't be messing with these manually, to be fair. I'm just trying to get a sense of, like, what I can even do. Hmm. That not seem weird. Reducing the number of environments should cause that much of a distinction. Oh, you know what? No, wait, we have stats evaluated over mini batches already, right? I don't think I can think of as the batch norm. Like, not even the batch norm layer, the advantage batch normalization. But that should not... How the heck is it possible that this completely and utterly breaks it? Yeah, no, it's over, Hmm. Okay. If this doesn't work, we must just be in some really unstable regime. Which, to be fair, you can actually get that from sweeps. Okay, well, actually, it seems there are good settings with fewer environments. If you can go find them. It just shifts the hypers a bit. One has not done very much yet. Hope it doesn't hurt. This is also good. This one here is very good, actually. Yeah, I like this. Holy. Yeah, this one's super good. Okay, so then there's just the question of basically putting all these things together and then whether or not you can find these in a standalone sweep. Do you work on this full time? Yes, Puffer is technically, well, not even technically. I mean, Puffer is a private lab. It's a company. We have a couple clients that pay for extended work around our tools. You get information here. I've been considering increasing this for a while now. Yeah, but for now it's here as is. Yeah, so you definitely... This one's definitely good. What's the time for this one taken? It was with one, Yeah, this is literally just 3 minutes. This is good. I like this one. Okay, so this is just like... The way that they consider frame budgets, they put the number of steps into it. So I believe if I just go to 512, 40 million frames. This is considered equivalent under standard definitions. Clip is not good, but we'll try it. Any recommendations for self-play? Like papers or like what? For how to do it? It works, but it's a pain. Look at the Dota paper. Your best reference. At the moment, yeah, gaming is one of them, but far from the only one, right? Low fidelity control, logistics, it's random stuff, even in finance. We've done animation generation work. We do stuff with like another private lab. Tons of applications. I mean, honestly, it's kind of crazy that there really are more applications of this stuff than there are of LLMs, if you really think about it. It's just that this is a lot less mature because it hasn't had all the investment. For stability, it diverges immediately for simple algos. Really? If you fix one of the opponents as random, does it train? Do that as a sanity test. Can you compete with Gorobi? No idea who they are. The idea is generally that... But here's the thing, like, not everything is just a mixed integer problem, right? As soon as real-world problems get messy, you end up needing to do learning. And the idea is that RL can handle messy problems, right? You don't need to get some clever mathematical reduction. All you need is a simulator and chuck RL at it. And we've already made RL a heck of a lot better than it was a year ago. Massively, massively better. We can already solve problems now with just like almost out of the box with just a little bit of work that would have taken a team in 2 years. And as the RL gets better and better, we will be able to solve more and more problems using our tech. Right now, I'm working on getting it to be to have a better compute to sample efficiency trade-off via a few different methods. What is the core trick that's have you done, but like, have you tried to train it against a fixed baseline opponent? Honestly, longer term, I'm way more interested in like RL applied to material science and biology and so on and so forth. Like the really simulation heavy areas of science. That's longer term. For now, we're gonna solve it. Okay, I mean, this is the regime that we're interested in, though, right? The regime where, like, you spend a few minutes on the problem, and instead of, like, 30 seconds, and you get 10x sample F. Yes, yes, fixed random opponent trains well. Really? Doesn't diverge or cycle. Um, the, like, most simple and best method for this is historical self-play. This is in the Dota paper. Then you're always doing some of your games against fixed opponents. Probably your best starting spot. Okay, well, I mean, this is decent enough here. Now, it does occur to me that this is not exactly the network that I tuned this for. Which is slightly better for lag. I don't have any weird settings, it's just the defaults. The stream. Okay, this is better as well. It's slightly janky hypers, but so pretty near solve. Right? Okay. I forgot the VF clip. I forgot this. That's it. 430. I think I'm going to re-optimize this thing for steps. Just throw everything I've done today at it. Okay, so it's kind of coincidental then that it's this wonky VF clip. Yeah, ish. If this doesn't. It's still pretty fast training. Still over 100K. I mean, to be fair though, right, you can get Atari to be pretty dang quick without frame skip. Let's see if this solves before 20 mil even. I mean 40 mil. It's also possible the update epochs don't help at all because it's already maxed that. This is just like... Good thing it's just trolling me, right? So with decay... Okay, having fewer ends definitely makes there be hyperparams that are better. That is definitely the case. Gamma decay doesn't have enough experiments to say. This one doesn't either. That's nice. This is nanned out. Not good. Maybe 4 is too much. When is RL a bad idea? When your problem doesn't fundamentally require interactivity. Or when you have, like, unlimited expert data. Or when you want to not be driven crazy by insane research. Yeah. I wouldn't be surprised if you can actually solve this thing in like 5 millenn steps or whatever. Yeah, because this is pretty much solved here, right? Oscillating a little bit. Yeah, so this is solid. 2 minutes, 10 mil samples. What is it? 40 mil frames, yo. Yeah. Okay, well, I think it makes sense now for me to just set up a sweep that incorporates everything I've come up with so far, right? I guess what we'll do, we'll cut it down to like 20 mil. Can I do blocks in, well, let's not do crazy blocks yet, right? I do like Atari 100K. Is that meaningful? I mean, that would be... I could actually do a really big sweep of that. They just did direct joint and torque. Direct joint and torque. Oh yeah. Why don't you can you just do that and have it work? Can you just do that and have it work? That'd be good. Did I ever tell you to do IK? I thought I told you to do FK, not IK. Let's do like this for a bit. Ah. Okay, so there you go. This will sweep. And then I think what I'm going to do is I'm going to call it a bit early today. And I'm just going to kind of monitor this and keep doing some experiments at relatively small scale, but not so small as to be just totally stupid. And then we'll just start pushing this slowly into sample F regime. And then what we'll do is we'll take 3.0, which we know what the data efficient regime is. We'll take the sample efficient regime, and then we'll figure a way to cover them both in 4.0 as well as integrate a few other things. I'm updating my output layer. Weston, this is a lesson in keeping your damn code clean. Like, that's how you not waste time on this stuff. Fun fact, by the way, so film was the reason that my first vision paper didn't get accepted, because it was published. They got it out like right before I could publish mine, and it was on the same benchmark with like basically the same performance. This was my original vision paper. This was like this crazy architecture where you assemble like this forking, like dynamic neural net for every single question you want to answer. And then it was like semi-differentiable, which was cool. Yeah. Yeah, so I think, what is it? We beat them on... This is actually film here. And I had a much smaller network. And I beat them, I think, on like this category and then on the overall. With like a tiny little neural net, which was cool. Theirs was like more scalable and didn't use all these annotations and yada yada yada, but like I had this tiny little neural net and it actually did pretty well. That was cool. I don't know, I was probably like 20 when I did this. Okay. Well, it's about 5. I think I'm just gonna call it slightly early today. I'm gonna go get myself dinner, and I'm gonna take it a little easy today. And then tomorrow, so tomorrow I have a super, like, obnoxiously early, very long meeting, which is gonna delay me. And then if as long as it's not 90 degrees, I gotta go run in the moderate heat. And then I should be here for a few hours in the afternoon to work on this stuff. So for the folks who've been watching all day, thank you for stopping by. This is a nice bit of progress on the initial sample F research. I think my best guess is we're going to be able to do like 20x sample efficiency with like 10x compute, 10 to 20x compute. That's my best guess. So I think we're going to get like a pretty clean trade-off up to a point. I don't know whether the results are going to be as stable across everything. That is the concern. So we will see about that. But yeah, this is all open source work. Check puffer.ai for details. Go to the repo. It's free. Helps me out a lot. If you want to get involved with the project, join Discord. It's a lot more accessible than you might think. If you're trying to get into RL, you can follow me on X for more content, including all of my guides. Thank you, and I will be back tomorrow. Bye.